Day 404 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 131, Palindrome Partitioning. The difficulty level is medium, but don't worry because we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Given the string S, partition S such that every substring of the partition is a palindrome, return all possible palindrome partitioning of S. All right, y'all. So that sounds simple enough, but before we go ahead and take a look at these examples, let's make sure we understand these definitions. So the definition of a substring is a contiguous, non-empty sequence of characters within the string, and a palindrome is a string that reads the same forward and backwards. So what we want to do is we want to create substrings out of this input string right here, and every substring that we create should be a palindrome, and then we can return them in this array or in this output as such. So let's go ahead and take a look at example 1 just to make sure we're doing this problem correctly. So in example 1, we have the input S equals a string A, and B. The output is a 2D array, the first array being a string A, second string, or it's 2D array of strings. The first array has a string A, another string A, and a string B. All of these, since they only contain one character, they all count as palindromes. So they fit the requirements of being a palindrome, even though it's only one character, because this one character is going to be the same whether we read it forwards or backwards. Then the second array of strings has the string AA, which is a palindrome because AA reads the same forward as backwards, and then B, just a single character again, but once again a single character counts as a palindrome. So these are the two palindromes that we can create with this second array. So I hope that makes sense to y'all. Just remember, we're trying to create all of the palindromes or all the substrings that are palindromes within this array, and then we are returning those substrings, and they all get their own separate array when we for each substring palindrome partition. So in example 2, it's pretty similar. It's just this time the input S is just a single character. And once again, like I said earlier, a single character counts as a palindrome. So we just return a 2D array with that single character with the array holding the string A. So I hope that makes sense to y'all. If it doesn't, hopefully once we get into the solution, it'll make a little bit more sense, but it's pretty self-explanatory. So let's go ahead and get into the fun part, the actual solution. Solution is not that difficult at all. Now, excuse me, y'all. The first thing we want to do is we're going to check if the input string is empty, and if it is, then we can just return an empty result or an empty array. So we're going to say guard, we're going to use a guard statement for that. We're going to say guard exclamation point S dot is empty, which means this exclamation point means S is not empty. That's why we put the exclamation point there first. Then we're going to say else if it is empty, we could just return a blank array. So just like that. Boom. Now we need to convert the string into an array of characters, which will help us for easier indexing. So for that, we're going to say let chars equal, that's going to be an array, open up the parentheses of S. Then we're going to say let capital N, that's going to equal chars dot count. Boom. Now we need to define a closure to check if the substring is a palindrome. So we're going to say let is palindrome equals, then we're going to open up the brackets, we're going to say open up some parentheses, and we're going to say low colon, that's going to be an integer, then we're going to say comma high colon, that's going to be an integer as well. Come outside of the parentheses but stay inside the bracket, and it's going to we're going to return a bool. So then we're going to say bool n. Then we're going to come underneath that and we're going to declare a variable called low. Set that equal to low. Then we're going to do, after the low, we're going to use a semicolon. We're going to declare another variable called high and set that equal to high. Then we're going to compare characters from both ends towards the center. So we're going to start from one end of the string or both ends of the string, and we're going to make sure that they match each other to make sure that it's a palindrome. So we're going to say while low is less than high, we're going to open up the brackets and we're going to say guard chars square bracket low, come outside the square bracket, equals chars square bracket high. Then we're going to come outside of the square brackets and we can say else. We're going to open up the brackets and we could just return false. Otherwise, if they do equal each other, then we're going to increment low and we're going to decrement high. So we're going to say low plus equals 1. Then we're going to say colon high minus equals 1. So that's going to check the first. We're going to check, say this is our palindrome, right? A, B, A, right? This is just an example though. But say, so first we're going to check these two. This A, the beginning and the end of a string. So we're going to check, or the array, we're going to check to see if this A matches the A at the end. And if it does, we're going to decrement it. And so we're going to, next we're going to move to this B. And then we're going to, we're going to increment from this A, which would be low, and then we're going to decrement from this A, which would be high. So then we're going to check to see if these two are equal, and if they are, then we found ourselves a palindrome. So just remember to start. This would be low, this would be high. We're going to see if they equal each other. If they do, then we're going to decrement this low, and this becomes low, and or increment low, and this becomes low, and we're going to decrement high, and then this becomes high, and then we're going to do the same thing to see if these equal each other. Boom. So that's how that works. Then we could just come right here and we could say return true. Boom. Now, sorry y'all. This, oh yeah, no, that's right. Just trying to make sure. Boom. Now we need to initialize the result array where result of I holds all valid partitions for the prefix. So for that, we are going to say, hold on, let me make sure this is correct. It should be. Just clean this up so it doesn't get too confusing. So now we're going to come right here. Boom. Then, so now we're going to declare a variable called result. And we are going to set that equal to, it's going to be a 2D array of strings. So we're going to say, or excuse me, this is going to be a 3D array of strings. We're going to say square bracket, square bracket, square bracket. We're going to pass a string in inside. Then we're going to come outside of these square brackets, open up the parentheses. We're going to say repeating, colon. It's going to be blank arrays. Then we're going to say comma, count, colon. It's going to be n plus 1. Just like that. Then we need a base case where there's one way to partition an empty string or no part. So we're going to say, come underneath this, and we're going to say result square bracket 0. We're going to set that equal to a blank 2D array, just like that. Now we need to iterate through all the positions of the substring. So we come right here and we say for end n 0 less than sign n. We're going to open up the brackets and we're going to try every possible midpoint that can partition from S0 up to n. So we're going to say for mid and 0 up to end, or excuse me, no, this should be 3 dots, up to end. Then we're going to open up the brackets. Then we're going to say if the substring S of mid up to n is a palindrome, so we're going to say if is palindrome, open up the parentheses, mid, comma, end. Then we're going to open up the brackets, and we're going to create that substring. So we're going to say let substring equal string, open up the parentheses, chars, square bracket, mid, dot, 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 end. Just like that. Now we need to append the substring to all previous partitions that end at mid and store them in the result. So we come right here underneath this let, and we say result, open up the parentheses, end, +1, come outside the parentheses, we say dot append, open up more parentheses, contents of colon, we're going to say result, square bracket, mid, come outside the square bracket, dot map, open up the brackets, and we're going to say $0 plus square bracket, substring. Boom, just like that. Now we're not done yet because we still need to return all palindrome partitions of the entire string. So for that, we could just come right here, and we just had to say return result dot last and put the exclamation point. Now let's go ahead and give this a run before we submit it. Make sure it runs properly. Okay. We have an error. Cannot find is palindrome. Oh, sorry, y'all. Should be an N right here. So let's run it again. See if it runs correctly this time. Okay. Let's see. Let's see. Cannot call function of value type string. Let me see, y'all, what's going on here. Let me see, y'all. I don't know. Sorry about this, y'all. Result n plus. Oh, so this should be these should be square brackets. Sorry about that, y'all. So now let's give it a run. See if that does the trick. Okay, cannot find result and scope. Oh, reselect there. Well, that's not how you spell result. So now let's give it a run. Let's see. And it's accepted, y'all. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see. And look at that, y'all. 20 milliseconds beats 95.71% of users. Not too bad. Those are some good numbers right there. So with that being said, I hope y'all all learned something today. And before we leave, make sure you get one more look at the code, read it, learn it, love it. Make sure you understand what's going on. That's the top part. Boom, then that's the bottom part. And yeah, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.